call is now being recorded.
Is this slide visible? Yes? Okay, fine. So let me summarize what we discussed in previous class. We started with randomness, right? So why do we need random numbers with respect to cryptography, and what actually the randomness is all about? And we also discussed few examples, real-time examples, and also we just checked one of the approach which is used to generate random numbers, right? So basically, the random numbers are very important in cryptography when you perform encryption or decryption on the data which you want to protect, or the data which is involved in the communication between two parties. Okay, so that is the basic thing you should understand. So which is the first method that we discussed in the last class? That is, which one? It is non-deterministic random number generators, right? So non-deterministic means it is not determined. I mean, the numbers which are generated using non-deterministic generators, you can't predict the sequence. Uncertainty is involved, and also it is unpredictable. And under this method, we studied it is classified into two types. One is hardware-based, another one is software-based. In hardware-based, we saw a special hardware devices required, isn't it? So because of which the method is very expensive, right? And the output of this non-deterministic generator, I mean the random numbers which are generated using non-deterministic generators, are random in nature. So because of its uncertainty or the unpredictable pattern. Okay. And also we discussed software-based non-deterministic generator, isn't it? Where we studied a few examples as well in software. Since no hardware is involved here, this method is easy to implement and also cheap to some extent, right? It is very cheaper to use it in generating the random numbers. So actually, this random-based non-deterministic generator rely on the randomness of physical phenomena detectable by the hardware content in a computing device. That is what we studied in the last class. And also we discussed the disadvantage of this method, isn't it? That is, it is very expensive, as well as if we have to produce two identical strings of strings which should be in random in nature in two different places, then it is not possible, right? It is impossible to produce such random numbers in two different places. So these two are the disadvantage with respect to non-deterministic random number generators. So now we'll start with the next method, which we call it as deterministic generator. Okay. So here, actually, the deterministic generators are nothing but algorithms. Please do remember, these generators are nothing but algorithms. Okay. So here you can see this is an algorithm. Oh, 1 second. This is an algorithm. Okay. The output of this generator, we call it as pseudo-random bit string, or you can say pseudo-random numbers. Okay. Deterministic generators are nothing but the algorithms, and output of this generator, we call it as pseudo-random bit string or pseudo-random numbers. Okay. And whatever the output that we get, that is pseudo-random number, which is generated with the help of deterministic generator, is certainly not randomly generated. Okay. We'll see why it is not randomly generated. I mean, why it doesn't have true randomness in further slides. But as of now, you just remember there are certainly not randomly generated. And each time for this algorithm, okay, if you run using the same input, if you feed the same input for this generator, then obviously we'll get the same output. Whereas in the non-deterministic generator, what happens after, in non-deterministic generator, whatever, if you give the same input also, you will get the different output. So that's what, that is the specialty of non-deterministic generator. So to remember, deterministic generator is an algorithm, and output of this we call it as pseudo-random numbers. Okay, and it is not certainly randomly generated. And if you if you feed the same input for deterministic generator, then you will be obtained with the same output. But that's not that should not be the case in encryption or decryption algorithm, isn't it? We'll see all those things in the video. Okay. So now you consider this diagram which represents the deterministic generator, where you can see in the figure a seed is considered and it is fed to the generator, okay, which is nothing but an algorithm, where you will be produced with pseudo-random numbers. Okay, so here you can see whatever the input that you are feeding to this generator is a secret input. Okay, and then which generates the output. See, whatever output you have got here, that will have no apparent structure. Okay, and then so those who are not aware of the input, I mean what input you have fed to this generator, those who are not aware of it will not be able to find out whatever the output that they have got here are not truly random. Why? If attacker knows what is the input, then it is easy for him to find out what will be the output with respect to deterministic random number generator. But here, since the input is kept as secret and he doesn't know, he is not aware of this, so whatever the output that he gets here, it seems to be truly random numbers. Okay, this is the because of this, we are using deterministic random number generators in crypto system. I hope this is clear to everyone. Am I clear to everyone? Please do reply, unmute your mic and answer me. Am I clear to everyone? Yes?
Yes, ma'am.
Okay. We'll move to the next part. Let me consider this example where you have studied stream cipher algorithm, isn't it? I mean, actual implementation of this deterministic generator we'll see here. This is not there in syllabus, but for the better understanding, I have considered this example. You can see here the plain text is considered on which you are performing encryption process, applying a key. Okay, you can see the key is written here. Okay, so on with you are performing encryption on this plain text. Performing encryption means what? You are applying some algorithm, right? Along with this algorithm, you are applying a key. Okay, with respect to symmetric key, you know the key remains same at the encryption process as well as at the decryption process. Now, whatever key that I am considering here is generated with the help of deterministic generator. That's why here it says pseudo-random byte generator. Okay, for this encryption process, I'm applying key which is in pseudo-random in nature. Okay, and after performing encryption, obviously you will end up with cipher text, right? Once it is received at the receiver end, the decryption process, algorithm is applied, where here also we apply the key along with the decryption algorithm. Here, this key is same as this key if we are following symmetric, right? Then here you can see the same pseudo random number byte generator is used. Okay, so when you apply this key along with decryption algorithm at the receiver end, the plain text is recovered. So why I have considered this example? Because this key plays very important role here. Okay, see, there are n number of encryption algorithms and decryption algorithms that are available in the public domain, right? So that's why whatever the key for the attacker, if he knows the algorithm, he can try out all the algorithms that are available in the market or that are in use. Okay, but you have to keep the key as a secret here. Since the attacker will have, I mean, he doesn't have any idea about this key, whatever we are using for the encryption, it is difficult for him to recover the plain text. Okay, that's why whatever key that we use for the encryption or decryption method should be a secret one, and it should be random in nature. Okay, so actually true random numbers, I mean, to generate true random numbers, it's very expensive. So that's why we go for deterministic generator. Okay, where you can follow n number of algorithms, okay, using which you can generate the pseudo random numbers. Okay, so that is all about this example. So I have already explained this diagram, and this is a basic model of deterministic generator where you input the seed. Okay, seed means the initial value that needs to be fed to the algorithm. Okay, when you insert, I mean, when you feed the seed based on the algorithm, it will generate the pseudo random numbers. Okay, this is the basic model of deterministic generator. Now the question is, what is the seed? Okay, the secret information that is input. I mean, the seed value should be kept as secret. See, in the yesterday's video, we have seen the seed value with respect to the machine using which the pseudo-random numbers are generated, right? If you feed 2 digits as input for the for the random numbers generator, that will give you 100 random numbers. Okay, if you feed 3-digit random numbers, if you insert 3-digit value as a seed to the deterministic generator, then that will give you 1,000 different random numbers. Okay, so that's why the seed is whatever input that you give to this generator should be kept as secret. That initial value we call it as seed. Okay, and you can see this is essentially a cryptographic key. Okay, and the seed is the only piece of information that is definitely not known to an attacker. That this is what I explained in the previous example. Okay, and then the next one is the generator. That means algorithm, right? So this is a cryptographic algorithm which produces the pseudo-random output from the seed. So the output of this generator depends on the seed that we that we feed as input for the generator. I hope this is clear to everyone. So this question is very important. They may ask you to explain deterministic generator. Okay, in that case, you have to explain it properly. Based on the marks, you have to explain. If they ask you for the 4 marks, you keep it short. If they ask you for 6 marks or 7 marks, you have to explain it in detail. Okay. So this deterministic generator overcomes the problem that we discussed with respect to non-deterministic generator, where I just mentioned this non-deterministic generator is expensive, and at 2 different places the same output can't be produced, right? So those problems are solved by using deterministic generator. Why? Because they are cheap to implement and fast to run. And 2 identical pseudo-random outputs can be produced in 2 different locations. So in this way, we can solve the problem that we face in non-deterministic generator. Am I clear? Yes? You all there, right? Answer me.
Yes, ma'am.
Okay. So next we'll see what are the properties with respect to non-deterministic as well as deterministic generator. You can see here I've just listed out the points. Whatever I have explained till now, that is what listed here. The first one is close to the truly random generated output, right? In non-deterministic generator, the numbers are generated using physical phenomena. That's why the numbers are truly random. Okay, whereas here we call random numbers are pseudo-random output, and randomness from the physical source. That means from the physical phenomena. Whereas here from the seed. Based on the seed, the random depends, right? And the next one is random source hard to replicate. Okay, it is hard to replicate, whereas here it is easy to replicate. And here, with respect to security, it completely depends on protection of the source. I mean, using which source you are generating random numbers, that is very important. If attacker knows that using a particular source you are generating random numbers, then obviously it will be easy for the attacker to attack your system. Okay, whereas with respect to deterministic generator, it completely depends on the seed protection. So if you keep seed value as secret, then your system will remain safe. And since hardware is involved here with respect to hardware-based non-deterministic generator, it is quite expensive compared to deterministic generator. Okay. The next, there is a video. I want you to listen to this. Okay. This is how software works while generating random numbers. Okay. Please listen to it and properly concentrate it, because you will understand it properly. What is the difference between non-deterministic and deterministic proper if you look at this video. Okay. Is it visible and audible to you? Please respond.
Yes, ma'am.
Hello, V. Anton Sprawl here, talking about how software works. In this video, I'm going to be talking about random numbers. You know what a random number is. It's like when you roll a die to get a number from 1 to 6. What you may not realize is how often software depends upon random numbers. Computer graphics, for instance, make use of randomness. As I talk about in my book, making realistic graphics requires tracking how beams of light scatter when they strike the surface of an object. But we can't possibly trace light scattering in every direction, so we have to pick a few random directions instead. Random numbers come up in video games all the time. When you fire a shell in World of Tanks, for example, the damage you do from a successful hit is a random number in a specified range. In games where we face off against monsters controlled by the software, it's usually a lot more fun when the monster actions vary unpredictably, which again requires random numbers. Random numbers are also essential for computer security. Every time you establish a secure web connection, your computer and the computer you're talking with exchange a pair of random numbers used to create a temporary encryption key, a process which is explained in the 3rd chapter of How Software Works. So all kinds of software uses random numbers. But how does software create a random number? This is a lot trickier than it may sound. You see, all the computer processor can do is precisely follow the directions it has been given. In essence, all software does is perform math with numbers stored in its memory, and then make decisions about which instructions to perform or not perform by comparing two numbers to see which is bigger. That's really all a computer does. So how does strictly following a set of instructions produce a random result? The answer is it can't. There's actually no way for software to produce a truly random number. So instead, software makes use of what is known as pseudo-random numbers. This is a series of numbers in a particular range that seems unpredictable, but is actually produced by a straightforward mathematical process. Here's an example of a software-based random number generator. This particular generator is going to produce pseudo-random numbers in the range of 1 to 10. We start with some number in this range, let's say 5. We call this number the seed. When we need a random number, we take the seed and multiply it by 8. Then we take the result, divide it by 11, and take the remainder. In this case, that produces the number 7. That's our random number. The 7 also replaces the 5 as the seed. So the next time we need a random number, we start with a 7, multiply it by 8, divide that result by 11, and take that remainder, which is a 1. We keep doing this every time we need a new random number. Now, the special numbers we used in the math, the 8 and the 11, have been chosen so they have certain mathematical characteristics and relationships with each other. We can choose different numbers if we want a different range of pseudo-random output. Again, these are not truly random numbers, but the series jumps around enough that it looks like it's random, which is often all we need. This method does have a couple of problems, though. The first is how we set the initial seed, which we chose as 5. If we always use the same initial seed, we'll always get the same sequence of numbers. So if we're using random numbers to determine the events players encounter in a game, if we start with the same seed, the events are the same every time, which is not really what we want to get out of our randomness. It's better if we start with a different initial seed each time. But how do we do that? Well, one way is to use the system clock. When it's time to generate that first pseudo-random number, we can take some part of the current time, like the number of milliseconds into the current day, and take the remainder of that by 11 and use that as the seed. Another problem is that the sequence produced by these sorts of methods is predictable to someone who knows the details of the particular random number generator. That doesn't cause any problem in games, but if we're relying on random numbers to generate temporary encryption keys for secure web connections, we don't want the possibility of someone guessing what those numbers are. Because of this, some processors have special circuits to generate truly random numbers for use by the software. Here's one way that's done. Imagine a room with a sofa and 2 lamps, one at each end of the sofa. You decide that you only ever want one of these lamps on, so you install special radio-controlled switches on the lamps, such that when you turn the lamp on the left on, it sends out a radio signal that automatically turns the lamp on the right off. And likewise, if you turn the lamp on the left off, it signals the lamp on the right to turn on. And the other lamp does the same thing. You turn it off, the other lamp goes on, and vice versa. Okay, so now imagine both lamps are off, and you stand behind the sofa, stretch out with your arms, and turn both lamps on at exactly the same time. So what happens? A signal is going to go from the left lamp to tell the right lamp to turn off. And a signal from the right lamp is going to tell the left lamp to turn off. Those signals would arrive at nearly the same time, which would turn both lamps off, which would cause both of them to signal the other lamp to turn back on again. So initially, both lamps are going to be frantically blinking on and off as the signals chase back and forth. But due to random, unpredictable variances, something like the chaos theory that Jeff Goldblum character talks about in Jurassic Park, the timing of the signals would wobble, and eventually one signal would get far enough ahead of the other that the pattern would stabilize, with one lamp on and one lamp off. This is an electrical version of flipping a coin. We turn on both lamps and see whether the left lamp or the right lamp stays lit in the end. If we wanted a random number in a particular range, we could run multiple trials. If, for example, we wanted a random number between 1 and 8, we could run 3 trials and consult the chart shown. The random number circuit in some processors works like these two lamps, and the output it produces is truly random unless our understanding of particle physics has some fundamental errors. For gaming or graphics, or most of the places where we currently use pseudo-random numbers, these truly random numbers are overkill, but they add an extra layer of assurance for computer security. Well, that's it for this episode. If you find software interesting and want to know more about how...
Yeah. Did you understand how software works? I mean, how random numbers are generated? See, the other applications also given in this video. Say, random numbers are used in video games, which you all very I mean, that is a good time pass for you all, right? In video gaming as well as in graphics, right? And it is used in cryptography as well. And it is also shown that how the seed value is taken, right? So since it should be very secret and it should not be very easy to predict for anyone. So that's why how the seed value is considered for the deterministic generator is also shown in this video. I hope you got a thorough knowledge about the seed, how seed is used, and the applications of random numbers. Is it clear to everyone? Yes? You should answer me. Anyone? Any doubts? It's clear. Okay, let me continue with the presentation. So if no doubt, we'll move to the next slide, okay? And one more thing I have to discuss before starting providing freshness. Whatever the seed that we consider for the deterministic generator is actually relatively short. See, if we consider symmetric key as an example, then standard recommended length for the seed is 128 bits. Okay, and let's discuss the weakness about this deterministic random number generated. One, with respect to the generator, I mean the algorithm that we use to generate the pseudo-random numbers. Okay, so this deterministic generators are basically, as I said, it's a cryptographic algorithm, and obviously it is vulnerable to various attacks because of their design, which is weak in nature. Okay, so using a well-deterministic generator is the best way to reducing such associated risks. And to avoid attacks, it should be well designed deterministic generator should be used. Okay, and the next thing is about the seed management. See, whatever the seed that we consider as a input for the deterministic generator. See, if the same seed is used twice with the same input data, then the same pseudo-random output will be generated. So this is a disadvantage, right? So thus, whatever seed that we use need to be regularly updated, and it should be managed well so that it should not fall into any person. Because you know that network is, various attacks are possible when there is a communication between the parties in the network, right? So that's why the seed which we are feed as the input for the deterministic generator need to be regularly updated and managed. Okay, so this management of seeds, how to manage this key, that we will discuss in the next module. There is a separate chapter that is key management. There we will see how to manage this kind of seeds and seed as well as other keys which are involved in the encryption and decryption process. So that we are going to discuss in the next module. So for today, that's it. Okay, the next topic, providing freshness, will continue in the next class. Any doubts? Please, if you have any doubts, let me know. Any doubts, students? Am I clear to everyone? Have you all followed whatever I explained? No doubts? Okay, then that's all in this class. We'll meet you tomorrow. Thank you all. You can leave the class. Thank you.